right? And I'm not sure if you remember the first one, right? But what does negatively skewed mean? Which one there for negatively skewed? Right? That's when everything shifts to the right-hand side, right? What will be the answer there for negatively skewed? Anybody remember? So when they say negatively skewed, right? Everything is shift to the right, right? So when it shift to the right, you just have your mean, right? You just have your median, and you just have your mode. So the mean is the largest, right? So mean is less than, median is less than mode. Okay. So I'm not sure if you might remember that one, but the other's doable, right? Try the others, right? And then we'll correct the first 15. We'll do our next set, and then we jump to paper 2. So what I will do is I'll do some multiple choice in between. When we do the review, I'll do some multiple choice. Right, so you'll get some multiple choice practice as well. This is 2020. Yeah, this is 2020. All right, let's correct it out, right? Everybody finish 1 to 15? All right, so let's go, right? Number two, they want the mode. So you're looking for the one that's most frequent. What's the mode here? What's the mode here, Olia? Yeah, so you're looking for the most frequent number of goals scored. So that'll be 2, right? So you're looking for the most frequent number of goals scored, right? You have 2 goals scored 6 times. All right, nice. Next, an example of sampling here, right? Remember, so I'll do a quick review through some of them. Remember, systematic sampling is where you take your sampling frame and you number them, right? And then you choose, let's say, every second person, right? So you must have a sampling frame and then you choose every nth person. Stratified, right, is where you group them off. And based on the size of each group, you choose by proportion, right? Convenience is just if you have 20 and you walk into a room, you pick up the first 20. Cluster is when you have all these groups, right? And then all these clusters, and then you start selecting, right, from each cluster. And then within each cluster, you're doing a further random sample, right? So what y'all think about number 3? Right, they give you a regional organization is made up of 8 regions. The CEO of the organization wants to get persons, opinions about the changes to make in the organizations. To do this, he takes a sample of 5 regions. From those 5 regions in the sample, he further takes a sample of 10 in each region, right? So you have these regions and then you're choosing regions and then within the regions, you're choosing. What does that sound like? Right, good, cluster, right? That's cluster. That's not stratified. Stratified from each one of the regions, you would have chosen the amount to make up 10. Or 10 from each one. But clustered now, you selected from the 5, and then within the 5, you get 10. Okay? 4, which one here is a sampling frame? Right? So a list of possible data values now. We don't like that. A list from which a sample is drawn, that's sounding okay. The breakdown of the population, not into groups, right? And enclosure with a set now. So the best one there is B as the best answer, right? Right, so as you can see, the multiple choice, right? You get the opportunity to revise everything, huh? So anything you're not too sure about in module 1, you let me know. My focus, as usual, is to focus on 2 and 3. For a population divided into strata, under which conditions it is preferable to use a stratified random sampling rather than simple? Which one here is sounding good? Right? Remember, you want to choose stratified over simple random, right? Right? In strata, you want to be able to have different groups, right? You want to have different groups. What you all think? Oh, wait, none of you more. All right, so let's start from the underneath, right? Stratas are equal size and each individual is equally likely to be chosen, right? That's not necessary. You could do a simple random there. Individuals in each strata are different. You definitely don't want that. You have large strata with few individuals, that don't make sense, right? So therefore, individuals in each strata are each like in many ways. So the best answer here could be E. Six. Which one here is the median? Was it total there? How much is sumpter? 60. Right? So to get the median class, to get the median, it will be 61 divided by 2, right? Which is the 31st. So you're looking for where the, well, 30.5. So you're looking for where the 30th person is and the 31st person is. Right? So this is 8, 16, 26. So it had to be in here. So your modal class is 24 to 26. Okay, so you're just looking for where they should be located. How many students scored higher than 70? So it's a cumulative frequency. So you're coming up here, you're reading off 70, you have 100, right? All of these students here scored more than 100. So it has to be between 100 and 120. So the answer is 20, right? That's the one who scored higher than 70. Lower than 70 will be well, but that would have been 100. Okay. Remember when you're plotting your cumulative frequency, this is a cumulative frequency, you use the upper boundary, right? So that would have been like about 70 in this case. So 100 represents all the people, 100 people who got less than 70. Number 8, you have your interquartile range. So we need to get Q3. We need to get Q2, sorry, Q1, right? So the answer is 6, right? This is your interquartile range where you divide by 2. That'll be a semi-interquartile range. Right? The number of students who collected more than 30, yeah, more than $30, right? Where is 30? 30 is somewhere here. How much is that? Coming around about here. Right, there's 32, 34 based on this. Right, so the ones who collected more than 30, that'll be up here. How much is that? 26? Sorry, 25, wait. Wait, the answer not there. Where is that exactly? Where did this stop? That stop on 55. Okay, all right, yeah, sorry. I thought it stopped at 60. And this value here looking like a what, 34? $35 is in the middle. All right, anyway, 21 not there, so we had to go 20, yeah. Just looking like it stopped at, anyway. The next answer not there. That stopped at 35? Anyway, the answer is 20, right? Because 21 not there. Are you okay with that one, right? You're okay with that? right? The class that contains the median price, right? So we need to find which class here contains the median price. So you would have to get it total again, right? What was it total here? Anybody work it out? 5, 10, 15. So can you do it over? Which one number? This one? Right? So the total in the class is 55. It's looking like 55. 30 here. 30 here looking like, we had to go 35, right? So those who got more than 30 is 55 minus 35, which is 20. Right? Right. This one here, to get the median price, we will have to work out the total, right? And anybody did that? All right, let me see if I could do that here. So this is 10, 11, 12, 13. So this one here is 13. Oh Lord, this one in the middle. They can just give it a number, you know. How much is here? 5, 6, 7. Anyway, and I'll see why. You all recognize what the column is? What I recognize, but look at the left hand side there. What is that? All right, so it's frequency density. So sometimes when the class widths are not the same, right? When the class widths are not the same, and you have to draw a histogram, you wouldn't be able to do, you will not be able to do up a frequency versus, well, in this case, stock price. So in a case like that, what you will have to do is to use your frequency density, right? How you just find frequency density? Anybody remember? How you find frequency density? So your frequency density, nice. So your frequency density is your frequency divided by your class width. Okay? So as I said, when your class widths are not equal, although all these here looking equal, right? You will have to, when your class widths are not equal, right? You will have to take the frequency, whatever the frequency is, and divide it by the class width, right? To get the frequency density. Right, so you want to be able to get the median here. So when they all equal, that's not too sure about, right? But they all equal, so we will have to still work it out. Anyway, probably have a shorter way. Yeah? Frequency density, as I said, is frequency divided by the width. So the frequency is your width multiplied by your frequency density. Right? So this we said was what? 10, 11, 12, 13. So this will be 13 multiplied by 10. This value here will be 6, 7, 8. How much is that? 8.5, 8.75. So that's 8.75 by 10. No, man. Must have a shorter way to do that. All right, so the long way is to work out the total. The long way is to work out the total frequency, right? And then do the n+1 divided by 2 to have an idea where the median class is. But it must have something shorter. Anybody know a shorter way to do this? Count the frequency density and divide by 2. Add up all and divide by 2. All right, well, let's just finish out this long way here, right? So this one here is 15 by 10, right? So that's 150. This one here is 6.7 by 10, so that's 70. This one is 1.2 by 10, so that's 20. This one is 1.2.3, so that's 30. This one is 10. This one is 10. Right? How much does that sum up to? How much is that? Right? Yeah, so just add 1 divided by 2 to come up. What you get? Add 1 divided by 2. And just as 0.5, kind of have a wonder in there. All right, so we're looking for 179.25. So that will be here. Right? That's where your median could be. The median will be between 10 and 20. All right, I will look up a shorter, if there's a shorter way to do this. Right, but we could see that it's positively skewed, right? And it's shift to the left. But still, you can't really tell between which one here it is. Right, you know this out for sure. Right, so, and this is 180. 180 is where? 180 is in this range here. Oh wait, here's what I did earlier. I think I'll leave out 1. I left out 150. Sorry, I left out 150. It's 130, 87.5, and 150. I left out 150. Right, sorry about that. Just check it back from me. Well, if it's 150, it will push it to 20 to 30. Yeah. right? So the answer is B. Right, yeah, correct, Grant. Right? I left out 150 there when I was adding it up. Right, so the answer is P there for this one. Yeah, it will be P. All right. I will consider as a shorter way to do that, right? But learn that one, right? If you have frequency, density, stock price, that answer is B. Right? What you could say about this distribution here? Positively skewed or negatively skewed? Well, you know it's not symmetric, right? You definitely know it's not symmetric. Yeah, just quick. Everything kind of shift, yeah. Everything kind of shift to the right. So you know it's positively skewed. All right, cut. 11, 12. You'll have a table. Check in the group, right? You should see the table. So a random sample of 4 numbers that lie between 0 and 5 inclusive, right? They want the numbers are given correct to 2 decimal places. Okay, so the random, so using the table provided, you want to begin at the 11th row. So you're going down to the 11th row from the top, right? 11 from the top, and the second column from the left. So you're starting with 2.43 and you're moving along. So you're going 2.43 and you're looking at the 3 numbers next. What's the 3 numbers after 2.43? Everybody have a table to look at? Everybody have one, right? All right, so if you go to a table, they said the 11th row, right? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're starting at, so the first 3 values are 2, 4, 3. So that's 2.43. The next 3 values are 4, 4, 2. Right? So that will be 4.42. Right? After 442 is 006. Yeah, 006. So your one varies between 0 and 5. So you could get 0.00, 0.06. Right? So it's looking like, oh, well, we have 3 options so far. And after 0.00, it have 8.72. So the answer is E. Right? So although you see in 006, you want your answer to 2 decimal places. Right? Right? 6. And then you're looking to see if your numbers between 0 and 5. Oh, wait. You can't include this. It's between 0 and 5. Right? So you have to skip out 8.72. And then your next 3 values are 107. Right? So that's 1.07. Okay? So that's D, not E. Right? So between 0 and 5. Okay, so the answer there is D. Everybody look at a table, right? So just for you to read the values off. They told you exactly where to start, and you just reading off 3 consecutive numbers and put the decimal in the right place. Then check and see if the value falls in the range. Right, that was 12, 13. Right, you have to find the mean age here. So because it's group data, right, remember it's the sum of fx over the sum of f. Right, and to get x, you have to find the midpoint here. So the middle of 12 is the middle of 5 plus 7 is 12 divided by 2, that's 6. Here's 9, here's 12, here's 15, here's 18. So those are your x values, these are your f values. multiply it, find your mean. Tell me where you go. All right, so multiply it out. Anybody have 2022 or 2021? I had it, I just can't remember where I shared it. Right, how about you all got there? Right, for those who work it out. See A, right? You just multiplying 6. You just to get f of x, you just multiplying 6 by 26 and so on, right? Multiply it out and then divide by the total frequency. So you add up this. Right, so I'm seeing the answer from most people who did it looking like A. Right, next one. Right, trim mean. So a 10% trim mean of the distribution to 2 decimal places, right? So a trim mean, well, I'm gonna just run through trim mean. If you have 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 values, right? So a 10% trim mean means that you're taking 10% of all your values, right? And that'll be 1. And then you're going to trim off 1 on each side and then find the mean of the remaining values. Okay? So how many values we have here? How many values we have here? 20, 30, 40 values, right? So a 10% trim mean, right? We have 40 values. So you find 10%, that will be 4. So you're chopping off 4. So you're chopping off 4 from here, and you'll be left with 1. And it's removing well, all the 5s and 1 of the 4s. Right? So it will look something like that. 1, 1. Yeah, 1, 1, and then you take off all the 5s and you take off 1 of the 4s. Hurry up, work out the B there though. What's the purpose of a trim mean? What's the purpose of a trim mean? Anybody remember? Right, to get rid of outliers. Right, very good. So any extreme values, you want to remove them, right? Yeah, so let's multiply f by x again. and work it out. Tell me what you get for trim mean. Remember, when you find a 10%, you have to remove it on both sides, right? Nice. How much you all got? Okay, I see in D and B. B? B, okay. 2.66. Anybody else got that? Remember, just multiply, you know? You just multiply 1 by 1, then you add it here and so on, right? Okay, nice. Antonio, all doing it there? Last one. Item 15 refers to the following table, right? Which shows the daily sales in thousands of 2 outlets of a company in a given 5-day period. A pie chart with radius 8 centimeters is drawn for a third outlet, right? Right, 8 centimeters is drawn for the third outlet. One is 8. C. Right, 8 centimeters is drawn for a third outlet using 6 centimeters as a radius for outlet A. The total sales for C when compared to A is? Right, how much does this sum to here? 4, 10, 20, 35. To the 6, yeah, 36. Right, so for the A, the area of A will be pi r squared, of course, right? So that'll be pi by 6 squared, which is 36. So this is 36 pi, right? So that'll be 36 pi, right? And now the area for C, area of C is 8, right? So that'll be 64 pi. Okay, so based on that, what will be the total sales for C? What you'll think will be the total sales for C? All right. So baseline looking like 64, right? There is a little formula. There is a little formula whenever you're comparing pie charts, right? And the ratio is just trying to remember. Right, is R1, right? So the radius in this case, so the radius of C to the radius of A is equal to the square root of the total size. So that would be the square root of we don't know this one. And the next one here will be the square root of 36. Okay, so since the radius of C is 8 and the radius of A is 6, then when you cross multiply and solve, right, you'll get X to be equal to 64. That's a formula that could work as well, right? Right? Or by just comparing the areas, you should be able to figure it out. Right? So you can make a note of this. Right? Are you okay with that there? Next up, are you okay with that? Rajiv? All right. Anybody out 21 or 22? I looking for mine. Hold on. I have 22 in all this. Yeah, paper one. I just can't remember where. Okay, well, I find back. Oh no, that's unit 2. All right, don't worry. I found unit 2. All right, I'll look back for that. All right. So good. So you kind of get a run through a module 1 there, right? When I find 2022 and the answers, I will send it, right? So you can run through that. Let's begin the review of module 2. Right? When I find it, we'll come back and do it, right? I think I saved it. Chemistry, biology, pure maths. Now, finding the other years. All right, so let's begin our review of module 2, right? Module 2. Anybody have issues with anything in particular in module 1? Right, if you want, you could always go back to the first crash course video, right, on module 1. Right, but I want to kind of focus a little more on module 2. Okay, the first part of module 2, oh shucks, this one don't have it. Anyway, I will do it over, right? The first part of module 2 has to do with your probability. All right, so let's spend some time going over the probability there, right? All right, so quickly, we know to find the probability of any event, number in A over the number in the sample size, right? We know that all probability is between 0 and 1. And we also know that the probability of A not happening is 1 minus the probability of A. If I give you 2 sets and the sets intersect, the probability of the A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. We need to remember if A intersect B is 0, the events are mutually exclusive, right? It means that it do intersect. Then in these questions as well, we need to know if one affects the next, right? So if A is dependent on B, then we have conditional probability. We have the probability of A given B happen, right? This is A given B. That's the probability of A and B all over the probability of B, right? We need to also remember that if I ask you to find the probability of A and B, there's the probability of A given B by the probability of B. Okay, so we need to remember those small things. Then, if A is not dependent or independent on B, then the probability of A and B is equal to the probability of A by the probability of B. That is only if they're independent, right? Because if you look here, if A is not dependent on B, then the probability of A given B is quite simply the probability of A. Okay, so if one not dependent on the next, right, then the probability of A given B is the probability of A. That's the reason why the formula becomes this, right? So within a question, you have to identify if it's independent or if it's dependent. Okay, you have to look out and see if it's independent or dependent. Right, and then we need to understand tree diagrams. Tree diagrams are used for conditional probability. All right, so if I give you, for example, I used this with the form 5s last night, right? Studying and getting a grade 1. Right, from this node, you could either study or not study. This is the probability of studying. This is the probability of not studying. And then you could get a grade 1 given that you study. And you could not get a grade 1 given that you study. Right? We'll make up some numbers to it just now, right? That probability should be low. Right? Then you have getting a grade 1. Getting a grade 1 given that you didn't study, right? That'll be low as well. Probability again, not getting a grade 1 given that you didn't study. That'll be high. Okay. So based on this information here, we could find a few things. If I ask you to find the probability of studying and getting a grade 1, right? You're looking for the branch that has those two things in it, studying and getting a grade 1. So you're multiplying along the branch there. So that'll be the probability of S by the probability of 1 given S, right? if I ask you for the probability of not studying and getting a 1, right? That'll be the same thing. You're looking for the branch with not studying and getting a 1. You'll notice once you're going along the branch, you're multiplying. So the probability of not studying by the probability of getting a 1 without studying. Now, if I said here, here's what, I would like to get the probability of getting a 1, right? To get the probability of getting a 1, you have to look at all the branches that have that same thing in it, right? A 1. So how do we get a 1? We could get a 1 by studying and getting a 1, or we could not study and get a 1, right? And these two things are what we found here and here. Okay? So in short, if I ask you to find the probability of getting a 1, you're looking for all the branches. So you're going here and here. You're going here and here, right? Along the branch, you multiply different branches, you're going to add. Okay, so that's what I did here. Okay, so those are the things that we need to know about probability, right? Right, you all should have those things. If you don't have it, just screenshot it now. Everybody got the first one? I'm just going back to the first one in case I didn't get it. Right, that's the first part of module 2. The second part of module 2 has to do with your discrete variables and your continuous variables. Right, everybody have it? All right, so that's a probability. We will do questions just now, right? Anybody writing? Crap. My plan done, I forget. Right, let's take a look at discrete. All right, sorry. Right, so we need to remember about discrete variables, right? Here I have a little slide just to remind you a few things about a discrete variable, right? Or like, feel free to screenshot it, right? So a discrete variable, all the probabilities always sum to 1, right? If you look at this probability distribution function, this nice little table, it shows you that the possibilities of x, or the discrete values of x, are 1, 2, and 3. And the probabilities of each are A, B, and C respectively. If you add up all those probabilities, you should get 1, right? That's how you know if it's a probability distribution function, right? It must sum to 1. The next thing that we need to know is how to find mean, right? Mean, you simply multiply the x by the probability, and then you add them up, right? That'll give you the mean. To get E of x squared, remember, this is really E of x. To get E of x squared now, you're squaring this, squaring this, squaring this, and you're multiplying it by the probabilities. That'll give you E of x squared, right? And once you have E of x squared and E of x, you can find variance of x, right? Two quick things to note. E of ax plus b is a by ax plus b. Variance of ax plus b is simply a squared by variance of x. Variance of any constant is 0. Nice. And once you have a discrete, once you have variance, you can find standard deviation if you need to, right? Right. If you have two variables, x and y, right? The e of xy, you add up the e of x, add up the e of y. Similarly, variance. Okay. If they give a cumulative distribution, then you have to remember that the capital F of x is used to represent the frequency, which is the probability of x is less than x. Okay. So if you see capital F, if you see capital F of 2, it represents the probability of x is less than or equal to 2. So it cumulates, just like a cumulative frequency table, it cumulates all the probabilities that are less than 2. Okay, and one of the special discrete variables, discrete distribution, sorry, is the binomial. Right, the parameters of the binomial are the number and the probability. Okay, and to find any probability, right, to find any probability within a binomial distribution, you're using this nice little formula here. Right, P is the probability of a success, Q is failure, right, which is 1 minus P. To get E of x is N by P, to get variance is NPQ. And of course, if they ask you to list the conditions that define a binomial, you have to be able to list all 4 conditions. Finite, trials are independent, outcomes are either success or failure, and P is the probability of a success. It's the same for all the trials. Good. So that is your discrete variables. Of course, we go on the questions and all, right? But where did I stop in the last crash course? We did 22, 21, 19, 18, 17 as well. Up to 17, okay. So I want to do some of the older years. What you could probably do is remember, just check back and see if in between I didn't do some parts, right? Everybody screenshot that, right? All right, so that is your discrete variables. Let us see if, I feel like I had this thing back to front, see? All right, and I have a continuous somewhere. Hold on. Are you okay there? All right, anyway. So for continuous, the main thing with continuous is the normal distribution, right? All right, before we jump into this, we need to remember what's a continuous distribution, right? So for example, if I give you a continuous distribution here, let's say that's f of x. This area here represents the probability. Right? And that probability, that area or that probability is equal, total is equal to 1. Okay? So if I ask you to find the probability between A and B, what you're really doing is you're finding the area under the graph, right? You don't have to integrate anything. You just find the area using, in this case, trapezium rule, right? The area under the graph will give you the probability, and in this case, that value is 1. Okay, and the mean continuous distribution that we are going to do is the normal distribution. All right, everything here is in your summary, right? So we need to focus on the normal distribution, and the parameters. The parameters of the normal distribution are the mean and the variance. Right, A of x is the mean, variance is sigma squared. Right, the table that we have in our booklet, right, is the standard normal. Right, the standard normal distribution has a mean of 0 and variance of 1. Okay, and it's denoted by z. So if I give you, for example, if I give you a distribution like this one that is not standardized, to standardize it, you take the x value, you minus mu, and you divide it by sigma. So if I ask for the probability of x is less than or equal to 22, and it belongs to a normal distribution of mean 12 and variance 2 squared, then to standardize it, real simple, we take in the 22, we minus 12, and we divide by sigma. Okay, and then we could go to the table, and in the table we could, well, of course that value too big, right? But we could go to the table and read these values off. All right, when you're in your table now, and the question said the probability of z is less than a, all you have to do is take the value from the table, because the table will always give you all the less than values. If on the other hand they wanted more than, well, you'll have to take the value for a and minus it from 1. Right, so when you read off phi of a, you minus it from 1. Right, and if they said minus a, probability of z is minus a, more than minus a is the same as phi of a, right? Because if you wanted this value here, that value is the same as this value here, if a is here, right? So these two here have identical areas, right? Because remember, the normal distribution is symmetric, right? So the areas, both shaded areas there, those areas are equal. Okay, and if it's z of less than a, that's a rule there. Okay, so you can learn the rules or you can learn to work it out, right? But I gave you all the rules here, right? That is for a normal distribution. Then you have some conditions here, right? You have to be able to read the table in reverse, right? Right, take a look at them here. Ignore this, of course, ignore the plus one, right? Made a mistake and put that in. Right, but if your binomial distribution is too big, right, NP is more than 5 and NQ is more than 5, then you have to use an approximation that will make it into a normal, right? But remember, when you're going from a binomial to a normal, you have to use continuity correction. Anybody remember? If x is more than or equal to 5, let's say, if you have probability of x is more than or equal to 5, what will be the continuity correction for that? Okay, right? So remember I told you what to do. List out a few of the values. More than 5 is like 5, 6, 7. So what was the smallest continuous value? That will be rounded off to 5, and the answer is 4.5. So x is more than or equal to 4.5. If on the other hand I had x is more than 5, then the first discrete value here is 6. So the smallest value that'll give you 6 is 5.5. So that'll be the probability of x is more than or equal to 5.5. Right? So you would apply continuity correction. You would apply continuity correction when you're going from something discrete to something continuous. One last one. Suppose it was x is equal to 5. What would it be there? What would the continuity correction be? If it's x is equal to 5. Right? Because it's equal to 5 is only one value, right? So you need to get a range of values that will give you 5. So the range of values I'll give you 5 will be 4.5 to 5.5. Okay, so the continuity correction will be all the values between 4.5 and 5.5. Not including the 5.5, right? Right, ignore this, huh? Nothing to do with Poisson, right? That's unit 2. Any questions? Any questions, Olia? All right, so we will start our review with multiple choice. All right, so let's go back to that paper, right, and do 16 to 30 from us. Right, and then we'll go into some paper twos. Go ahead. Please try it, huh? Right, you could take a 5-minute break if you want and then start it. Right, I'll give you a lot of 5-minute breaks. Go ahead, do that, please. Right, how much charge I have here? 30. Right, you will see when you finish, right? Shh. You'll finish, it's only until 30. Tell me when you finish, right, please? Right, one person finished so fast. Hurry up. Right, anybody else working still? I have one, two finish alone. Antonio, all done? All right, I gave you enough time there, right? Antonio, you finished now? Rajiv, well done. Dexter, Ciara. All right, so let's go, right? So figure 16 refers to the following table, which shows the probability distribution of a discrete random variable. So they want the probability between -1 and 1. So that's this plus this plus this. What's that? 0.6. See? Yeah. All I get up. See? Next one. They want the probability of x is more than 25. So we know we have to standardize, right? So that's the probability of z is more than 25 minus 24 all over 6. So that's the probability of z is more than 1 over 6. I have a calculator, so I want to help me there. So that'll be 1 minus 5 of 1 over 6 because it's more than, right? How much you all got there? B, 0.4336. B, okay, nice. So good. So at least we read it off the table properly, right? Right. It's always nice to start with some multiple choices, give you a little practice on some of the things that you'll meet in paper 2 as well. So now you have a discrete variable y, right? Stop me if you don't understand something. The discrete random variable y, where y takes on these values, the probability of y is equal to 3, right? Remember, capital means cumulative, right? Right? So this value is for everything less than 2. This is for all the values less than or equal to 3, right? So therefore, to get equal to 3, you have to subtract this and this, right? And that will give you 0.8 minus 0.58, that'll be 22. See? Are you okay with that? Right, so remember capital F is cumulative, right? And this here represents the probability of y is less than or equal to 3. Next one is less than or equal to 2, so subtract and you will get equal to 3. All right, 19, mutually exclusive, right? They don't intersect, right? So this will be the probability of A plus the probability of B complement, right? So that will be 0.2 plus 0.2. So this is A union B complement. Right? So that's 1 minus. Oh wait, but it did intersect. Hold on. Right? So this is A and everything outside A. Right? So that's 1 minus probability of B, 0.9. Anybody got that? Should be able. Right? So they want A and everything outside of B. So that's 1 minus. Right? That's 1 minus everything in B. Right? So you need a diagram to kind of get that one correct. Right? So you have a normal is used to approximate a binomial. Right? So what will this become? You're not including the 40. So it'll be 41 and you're including 45. So the smallest value that'll give you 41, sorry, is 40.5. And the biggest will be 45.5. Cut. Right? So that's the continuity correction there. Everybody okay with that? Next one. 2021. What? How come correlation? Anyway, which of the following scatter diagrams shows negligible correlation, right? So the scatter to be kind of all over the place, right? I didn't really show you this as yet, but you should know. Which one here? A, B, or C, or D? Yeah, C. C kind of like that, right? No correlation. That's supposed to be module 3 anyway. Right here, between -3 and -1, it's already standardized, right? So -3, -1, that's just this little area here. Right, 3, 1. What you all got for this one? You could use the actual chart so you can work it out. Which one here correct? A, B, C, or D? Right, those two areas, they're supposed to be the same, right? Right, remember, if you're not sure, you can just go back to the summary. Look at the summary. Right, yes. Send some answers now. Look what you all think. The two values negative. The two values negative. What you got? Right, can I give you a hint right here? I will draw a diagram for you. Both areas are the same. So between -1 and 3, -3 is the same as between 1 and 3. Yeah, hurry up, just message quick. I want to make sure you'll catch this one. All right, nice. Yes, the answer is B. Right, I'm going to show you why, right? All right, here's -3, -1. That's this area, right? That area is equivalent to this area here, 1, 3. Right? So to work out this, you need phi of 3 and you need phi of 1. And then you subtract them. All right. Right, so that's B. So the answer is B. Here, we have probabilities, find the probability L. So all we have to do to get the probability of L is look for all the branches with L, right? So that'll be here. So that'll be 0.6 by 0.25 plus 0.4 by 0.8. Right? What you all got there? B, all right, nice, B, good. All right, next one was shops. Anyway, so so you all got B as said here, right? So the probability of this will be the probability of not L and B. Not L given B. Oh wait, no, that's simple, man. We don't want to read that. We can read that off here. Yeah. This here is the probability of L given B. This here is the probability of not L given B. All right. So that would be 0.7. As I worried, I don't want to get sick. That's the problem. Yeah, so that's 0.75. Okay, so 24 was apple. All right. That's 24, right? 25 now. If the letters of the word school are arranged at random. Wait, what the hell is this? I wonder if I leave out something when I was. This is normally a unit 2 thing. All right. Sorry, earlier. I think I had to teach over. I teach something, right? Called arrangements. Did I show you all this when we were doing module 2? How to arrange something? No? Okay. This is 2020. Anyway, this is supposed to be a unit 2 thing, right? But I'll still show you it. Right? So to arrange A, B, C, to rearrange it, right? Okay. All right. That's 2019 as well. Okay. Well, I will show you how to do arrangement. It's real simple. All right, but I thought it was just a unit 2 thing. All right. So A, B, C, right? How do we arrange things? Well, to arrange, for example, A, B, and C, we could have different arrangements. First arrangement is A, B, C. Next will be A, C, B. I'll give you the formula just now, right? Third is third will be B, A, C. Fourth will be B, C, A. Now I will keep C the same. I'll keep the first as C, so that'll be C, A, B. And 6, that'll be C, B, A. Those are all the possible arrangements of the letters A, B, and C. So the answer is 6, right? So there's a formula that allows us to get that. The formula is called n factorial. N factorial is simply, you start at 1 and all the integers until you reach n. You multiply them. But if you go take calculator, which I do not have, but go take calculator and look for this symbol, factorial. So here we have 3 letters, so that's 3 factorial. So that's 1 by 2 by 3. Okay, so that'll be 6 factorial. Sorry, 6. Go take calculator and see if we can find 3 factorial now. All get? 3, right? Press 3 factorial and should get 6. Yeah. Right? Check if you had 4 letters instead. If you had 4 letters, what is 4 factorial? Right, 24, nice. Okay. But sometimes it will come this simple. Sometimes instead of 3 different letters, you might get this A, B, B, C. So you might end up with common letters. So when you switch them around or rearrange them, you kind of end up with the same arrangement. So if I switch these B's, I'll get A, B, B, C, same thing. So these 2 are the same arrangements. So in a case like that, the formula has to change. The formula will be 4 factorial over the number of B's, or a number of common letters, factorial. So the answer will be 4 factorial over 2 factorial. Okay, so the formula is like n factorial over p factorial, q factorial. P and q are the common letters. All right, I'm gonna give you an example here. All right. So I didn't find that up to now. Antonio, Antonio messaged me and told me he can't find factorial. Antonio, you is good trouble on the way. Right? Look, factorial right here, Antonio. Hold on. Eh? Right above, right under x squared. Right? It's not any, like x factorial. See it now? All right, good. Right, so let's look at the word statistics, right? It has a S, it has a T, it has a A, a I, and a C. All right? It has 3 S's, 3 T's, 1 A, 2 I's, 1 C. So in total, it has 10 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So how are we working this out? We're using this formula here. 10 factorial for the total number. P factorial is the number of common S's. That's 3 factorial. Common T's, 3 factorial. Common I's, 2 factorial. And that's it. That's the number of arrangements. Work it out, please, in a calculator. Tell me how much you got, please. I got it today. How much is that? $50,400. Okay, nice. 50,400. Sometimes you will see the answer looking like that. Okay, so that's the way you handle arrangements, right? There's something called NPR and NCR, but I think that is unit 2 for sure. That's why you have to choose and then arrange. Okay, are you okay with arrangements? I'm gonna give you one more now. Saskia, are you okay with us? Grant, you all did this in school? Anybody ever do this in school? Okay. All right, just do mathematics now, please. Yeah, NCR and NPR are supposed to be modules. NCR and NPR is supposed to be your unit 2. Right, just do mathematics. I'm gonna tell me how much here. Oh. Oh. Right message answer, right? Yeah. Message all the answers, eh? I just want to see what you all got. Yeah, it will be big, right? Okay. Right? Right. So mathematics. Let's just check and see if I get that one right. Mathematics. How many letters we have? 1, 2, 3, 4, 5, 11. We have 2 M's. We have 2 A's. We have 2 T's. Right. We have 2 T's. 2 M's, 2 T's, 1 H, 1 E, 1 I, 1 C, 1 S. Okay, yeah. So 11 factorial over that. Right? You'll got that value 44,989,600. All right, nice. So let's come here. So sometimes now we have to do the arrangements, right? So if the letters of the word school are arranged randomly, right? What will be the probability that the arrangement begins with OO, right? So SCHOOL. So the two O's always together, right? So what other letters will go here? The two O's always first, right? So you're left with S, C, H, and L. So you have to arrange those four, right? So to arrange those four, that'll be 4 factorial, right? Nothing common there, right? If I switch these two O's, will that do anything? Right. Okay, so that's 4 factorial, right? Nice. But they want the probability. So what you're going to divide that 4 factorial by? Anybody can tell me? Right, so how much you dividing by? You're dividing by the total possible, right? So 4 factorial is how much? 6 by 4, that's 24, right? So the total possible is using the formula I gave you, right? 1, 2, 3, 4, 5, 6 over, you have 2 O's. What is 6 factorial divided by 2? Right, that's 360. Okay, nice. 24 over 360. How much is that? How much is that? 24 and 360? No, give me the fraction now, so you'll get the answer there. 1/15. Okay, so that's the way you work it out, right? Oh, shucks, I lost my cover. Anybody confused there? Anybody confused? Here's a way to do for me. Let's use the same thing, school, right? But I wanted to start with S. How we get the fraction is probability, right? So you work out 24 and 360 in a calculator, right? And you get 1/15. So it's 24, which is to answer what they asked us over the sample space. The sample space is the total number of arrangements, which was 360. Just we'll work out this seminar. The first 3 letters are right. The first 2 letters S and C, right? Find the number of arrangements. S and H, sorry, S and H, sorry, S and H. How much you all got here? So what will be different here? What will be different here in this question is that what will be different here is that you have to switch around the S and the H. So when you work out the total possible, it's still 360, right? Here we arranging the letters what? C-O-O-L, cool, hey, real cool. Right, so that will be 4 factorial over 2 factorial. Right, so that will be what, 12? Right, but the problem is we have an S and an H, so we could have switched them around, H and S. So we had to multiply our answer by 2. So that's 24 over 360, which boils back down to 1 and 15. And you all said that, 1 and 15. 24 and 360. Okay. All right. Spend some time on that because I didn't really do that before, right? Here. Can you explain it over? Oh Lord. Let me see. Did I delete that? Okay. So watch here. So remember the word is school. The first 2 letters I want are S and H, right? So those first 2 letters could be SH or HS, right? So whatever you work out for SH, you multiply that answer by 2, right? So if you have S and H first, the word is, the letters remain is C-O-O-L, which is 4 factorial, right? But you have 2 O's. So it's 4 factorial over 2 factorial, which I think is 12. And you have to multiply 12 by 2. Okay, 12 by 2 will give you all the options. And then that's 24. So that's 24 over the total possible, which is 360. All right. All right, let's go back here. Let's go back here. So E of X is how much here? What you all got here for E of X? B, nice. Right, so you know what the probability of X is equal to 0, right? Everybody okay with this one, or you want to work it out? I'm gonna work it out because I want to get one answer. Right, so in a question like this, we have to work backwards, right? So it's NCR is equal to, sorry. Right, NCR is equal to P to the N minus R by Q to the R. So NCR is equal to P, which is 0.4, right? R is 0, right? 0.4 to the N minus R, so that's 0. So that's Sn, and this will be 0.6 to the 0. This value here is 1. this value here is 1. Right? So what that means is 0.4 to the n is 0.1. Right? Oh, I'll be back to the front, sorry. Oh, that's true, yeah. Sorry. It's Q and R. Okay? So I'll just switch them around. There's 0.6, 0.4. Right? So anything, n is 0, no matter what n is always 1. Right? 0.40, and take the power 0 is 1 as well. So it means that 0.6 to the n is 0.1296. Pure math people who do add math something, you can take logs on both sides. Those who didn't, my advice here, plug in the values and see which one are the n values, or no, you still need p. Oh gosh, yeah. So you had to take logs here only. So it will be n. So you take logs on both sides. So log 0.6, you put the n in front, is equal to log 0.1216. So n is equal to log 0.1216 over log 0.6. How much is that? What's that value there for n? 4? 4? Okay, nice. So the value is 4. So the expectation is n by p. So that's 4 by p. P is 0.4. So that's 1.6. All right. Okay, nice. So that is that. That's NPQ. Next one. The heights of rose plants follow a normal distribution. The heights of rose plants follow a normal distribution with a mean 215 centimeters, and I give you a standard deviation. They want less than that. So they want the probability of X is less than 200 centimeters. And they told you that it follows a normal distribution, mean 215 standard deviation, 20.2 squared, right? So the first thing we do, we standardize. So that's 200 minus 215 over 20.2, right? That's the probability of Z is less than what? How much is that? Minus 0.743, right? So remember, less than or minus value is this small area here. So that'll be 1 minus 5 of 0.743. Go to your tables, work it out, minus someone. Tell me what you got. Should be a small value, so I don't think it's C, D, or E. Yeah, B, nice. Sometimes you can kind of guess, right? The value for sure is not this and this. Right, because it's a small little shaded area here. Okay, good. Next one. An unbiased tetrahedral die is rolled twice. Tetrahedral means 4 sides, right? What's the probability of getting a total score of 4? Oh, it's rolled twice. Okay. Right, so you're rolling it twice. 1, 2, 3, 4, 1, 2, 3, 4. All right, here will be 2, 3, 4, 5, 3, 4, 5, 4, 5, 6, 5, 6, 7, 6, 7, right? So you see you have 16 options and they were to get 4. So you're only seeing 3. So the answer is 3 on 16. Right? So you need a sample space diagram to make sure you have everything. Okay. Let's go again. Next one. It is estimated that 30% of a population of a country holds university degrees. If 10 citizens are drawn at random, what's the probability that at least one? So you should recognize that this follows a binomial. N is 10, P is 0.3, right? They want the probability of at least one, right? So that's one or more. At least one. Okay, that's one or more. So that's 1 minus the probability of x is 0. Right? So you use the formula NC0 by Q. Q is 0.7 to the 10 by 0.3 to the 0. How much is that? Well, 0.7 to the 10. Right? And then you minus 1 from it, right? Right? Then you minus 1 from that. So the answer is 2. Nice. Right? And then you minus in 1, right? So the value you should have gotten here is 0.028. And then you have 1 minus that. All right, last one. Then we can do some paper tools. Right? In each round of a game of cards, a player can either win or lose the round. Right? You take your time with some of these. Huh? The player can either win or lose the round. The probability of winning the first round. The probability of winning the first round is P, and the probability of losing the second round is 2/5, right? So this looking like the first rounds. You could win or you could lose. So what is number 27 and number 29? Hold on, I'll come back just now. 27, the answer was, I forget. What was 27 again, Olia? 27 was boy. And 29 was what? Dog, right? All right, sorry. So the probability of winning the first round is P. So losing a beat. This here is the first round, right? The second round. How I need to use a tree diagram because it appears to be conditional, right? But it's looking like that. The probability of losing the second is 2/5, right? Independent of the first round. Okay, scrap that. Scrap that, right? It's not a tree diagram, right? So find the probability. 29 wasn't 8, 29 was dog. You had to minus 1 from that. So 29 was dog, right? Yeah, 29 was dog. So the probability of winning the first round is P. The probability of losing the second round is 2/5, right? Independent of the first round. So the probability of losing the first round and winning the second round is what? What will that be? right? Well, this is just to give you a little idea, right? So that will be 3/5 on top. So the best answer looking like what? The probability of losing the first round, that's 1 minus P. And winning the second round, that's 3/5. So the answer is dog. Right? Forget this, eh? That was just to depict what's going on. There's not a tree diagram. Okay? Everybody okay with that? So that's dog. All right. So let's start a little paper 2 here. Oh, boy, it's still taking long. Hold on, eh? I'm just trying to load it. All right, so I'll start from I'll do a few 16 and 15. If you have it, you could open it up. Why it's not working? Wait, so I had to go back here. I'll load it from here. Anybody can share 2016 with me? I'm trying to load it from a file I have here, but it's not loading. Let's try one more time. Anybody can share 2016, please? Thanks. Yes, session 15 one time, right? All right, so we try in 2016, we leaving out that, we do the module 2. Right, take our 10 minutes, see how far you can reach. Apply should be one of the fastest exams that you would do. Should be easy. Reach to number 3 and 4. Right, try it, please. Try 3 and 4. Everybody have it? You can always go and keep past papers, or you could check in the group, right? Right, if you do it already, well, you could just rock back and wait till me to correct it. You only a lunch break, or you could eat and work. On the home, so they eat and work, right? For what? Why you going on in the lunch break? You know where to go, you know cards to play. You're home by yourself. Eat with your left hand. What numbers? 27 and number 29. What the answers? If we just give it, somebody just tell me again. What was the answer for 27? I think was B, and 29 was D. B and D, yeah. Right? Saskia do that over here about 2 years ago. All right. Right? Do number 3 and 4 here, please. How long you need? All right? 10 minutes. All right, try that quick. And then let us see. You already know lunch break and all, you're home. All right. So we can squeeze in 2 now, the 50, 16 and the 15, and then I'll give you 10 minutes to go and eat. All right, I can try Tuesday if you want to do some paper 2s again. You have to come in school on Tuesday. I'll be there till 5. But I have a next crash course going on, so I'll just be like checking your work for you now and again, right? The exam is in the morning or the evening. The multiple choice, oh God, in the evening. Oh. But I will finish that real fast, so I could be there by 2 o'clock, can't I? Both of them? Oh, okay, yeah, and I'm not interested in the papers, right? So if you want to come in the morning and practice some multiple choice, you could come and then go to the exam, or you could come after the exam. The exam will start at 1 and you'll be done by about 1:15, right? So you could come into school for like 2 and I'll be there till 3, and you could do some paper 2s. All right, take a few minutes. No, and paper 1 first. Right, no, what I mean is if you want on Tuesday, after you do the paper 1, well, all in school already, just stay in school and practice some paper 2s. Right, some more now. Today you might get 2 years in this, and right, you might get to practice a few more years. You could do over the ones that we did in crash course too. Right? You have until like 5. I'll be there until 5. Probably later, but probably not. Right? And so you'll get some practice for Tuesday. Or they have nothing Wednesday. So I could probably even try. No. I might be able to do nothing Wednesday night. All right, good. Enough talk there. To do this out fast, I've given you 12 minutes again and I correct it. And then we'll do one more and then you can have your lunch. A small break. Oh, yes. Sleeping thing. I guess some sleep. I know football to watch. All right, as soon as I finish, just message, right? I'll start one time. 3 and 4. All right, I have a few people finished. I'm going to correct it now, right? Any more? That's correct. All right. So the effect of taking an antidepressant and so on and so on, right? Right. So we can work it out. We know here will be 0.3. We know here will be 0.2. We know here will be 0.35. Right? Okay, good. So we have those values. Find the probability that the drug is effective. So we're looking for 0.7 by 0.8 plus 0.3 by 0.35. Sorry, effective, right? 0.65. How much is that? That's part 2, right? 1? No, it can't be 1. 0.7 by 0.8. 0.0755. 8.755. Okay. What they asked for after? They said given that the drug is effective, find the probability that the person using it is a man. So is a man given it's effective, that'll be the probability of man and effective over the probability of effective. So the probability of effective was 755. Man and effective, well, we had to go back to this. Man and effective will be here, which is 0.3 by here, 0.65. How much is that? Point 258. Nice. 0.258. Good. All right, so that's the probability part of the question. Oh, I still have more probability. A department store is analyzing the method of payment that consumers use to determine sorry. Was a grant? So is it not E given M? Question said given the drug is effective. Right? The person using the drug is a man. So the probability of a man given it's effective. So it's M given E. Right? Not the other way around, right? E given M, you could read it straight off the table. Right? This branch here is E given M. This one here. That's the probability of E given M. Okay. Grant, you okay with that? Okay, good. Next one, a department store is analyzing the method of payment that consumers use to determine whether there's a relation between the amount of money and the method of payment. Okay. Well, yes, needed totals as well, right? Right. Sometimes you just needed totals in order to do the probability. Right. So the first one is what? 8 and 9. That's 17. Next is 47. The next is 36. How much is that? 10, 20, 50, 80, 100. Right, the one on top is 16. The underneath is 44. And the last should be 50. Yeah, 26 and 16. Oh, sorry, 40. Okay. What's the first thing they want? Find the probability that a person selected at random pays for his or her item with cash. 17 over. Any questions there? Right here, 0.17. Anyway, you all did it already, right? So I just want to keep this table here. So that's part one. Part two, let's pull it up here. Hold on, I'm just trying to pull up paper. This one is 16, right? All right, good. So the next thing they ask for is makes a purchase, right? Makes a purchase that costs between 50 and 200. So that'll be 44 over 100. Next, makes a purchase over 200 and pays with a debit card. Right, so you're looking for the intersection over 200 and pays a debit card. So that's 23 over 100. Okay. Uses credit card. So part 4, probability of using a credit card given that he purchases under 50. That's conditional, right? So that's intersection of both of them. Under 50 and credit card, that's 4 all over the probability of less than 50, which is 60. So that's a quarter. Anybody got that? Different question. Nice. Let's go again. Right. More probability. Oh, really? the probability in this one, you wouldn't get as much. Given two events R and S, probability of R is that, probability of S. So you just add in the top, right? So you're adding up your 0.6, your 0.5, and your minus in your 0.2, right? That's 0.9. Right, R given S, so you use the formula, R and S all over the probability of S. R and S is 0.2, probability of S is 0.5. Right, that's 2/5. State whether it's mutually exclusive. The answer is no, because the intersection of R and S is equal to R value, right? It's not equal to 0. State whether independent. Well, two things you can look at. Check out the probability of R and S and see if it's equal to R. Wrong. So it's not independent. Okay? Or you can multiply the probability of R by the probability of S, and you'll get 0.3. That is not equal to R and S. All right, and what they asked for after. Nice, number 4. All right, number 4, they gave us a few probability distributions. I wish it come nice. Oh, yeah. Yeah, well, apply this be easy, regardless of how it come, apply this be. That's the easiest example. Normally applied pure in physics, chemistry, and things, some other things. For each of the following state, with a reason whether or not it's a valid distribution. I would say invalid because that's negative. That won't happen. This one looking good because it sums to 1, right? So that's valid. This one looking like it's summing more than 1, so it's not valid, right? And there's the reason, right? First reason is negative. This one is equal, so that's good. The sum is equal. This one, the sum is more than 1. So therefore, not a distribution. This one here, they give you a cumulative density function, and they want you to show that K is 1/7. So we know that when you add up this, you'll get, when you find the area here, that'll be 1. So the area is half the sum of the parallel sides. So that's half of 10 plus 4 by the height, which is K. Right? So this is 10 plus 4 is 16, 14, half of that is 7. So 1 is equal to 7K, K is 1/7. Easy maths. What's the probability between 4 and 6? Well, just find the area. That is that area will be 4 and 6 as 2 by the height, which is 7. 2 7. Yeah, which one? 2. 4 and 6. Sorry. Yeah. Are they here now? You're here now? Oh yeah, I was set up the phone was ringing as well. Right, Reggie, what's the problem there?
I'd say, no.
Huh?
Yeah, all right. So if you put it in a PDF, it will be the probability of 4 plus the probability of 5 plus the probability of 6, which will be 3/7.
Probability of 4, 5. Wait, you lost me there. Oh, what I mean, like assuming if it discrete. Right, no, but remember it's a continuous random variable. So to find the probability for a continuous random variable is the area. It's the area under the function. In this case, it's the area between 4 and 6 of whatever the function is, right? In this case, you don't have to integrate, you just find the area there. That's 2 by 1/7. All right? Because if you look here, between 0 and 1, the areas are not the same. So like this area here, all that wouldn't be 1/7 and 1/7. Plus is up until 10. Okay, so the answer is 1/7. What's the next one? Search sounding like you in a snowstorm. Oh, right. I was feeling real hot. I put the fan on me there. Sorry. Better now? I don't have an AC up here, so I had to use the fan. All right, I can go back to my classroom. I forget. Right, now variance. Come on. I'm not going to work that out, yeah? Right, that's where you find E of X minus E of X squared. Right, some people got 44.6. Anybody else got that? So you find E of X by multiplying, and then you add them up. Then you find E of X squared by squaring and adding them up. Right, Barry got 44.6. Anybody else got that? Anybody else get 44.6? Barry, this better be right, yeah? I feel like nobody else got 44.6. Yeah, Barry. No, wrong. 18.84. Oh God, somebody get 50.2. Come now, don't make me work it out now. 18.84, good, I'll take that. I get 18.84 twice. So check back here working, right? Right, so they asked, remember they asked for E of X for variance, right? So that's E of X squared minus E of X all squared. Okay, Chelsea said you probably square the expectation. So what you all got for E of X squared? E of X is 5.6, right? And what you got for E of X squared? Good, 50.2. And when you subtract, how much you got? 18 point something. 18.84. All right, good. All right, Verk, check it back there. You forget, oh, you forget the square, yeah. Very good. Thank God that did not depend on your answer, right? There, how'd I get wrong? All right, thanks. Next one. Good job, Verk. Construct a cumulative distribution table. Well, I'll do it right here. right? So a cumulative distribution table, that's the one with the capital F, right? So what will that be? Right, for all the values less than 1, that will stay 0.2, less than 2, that will be 0.3, less than 4, remember this will be less than 4 now, right? That would be 0.6, then 0.9, then 1. Okay? So you just add it up. Right? Evaluate E of X is more than 4. You could just read it off, or you could, more than 4 will be 0.3 plus 0.3 plus 0.1. Right? More than or equal to, so you're including it, right? Next, Paddy. Right? They said 60%. A market research has shown that 60% of persons who are introduced to a certain product actually buy the product. So it looked like P is 0.6. They said 80 persons are introduced, determining number who's expected to buy. So E of X is equal to 80 by 0.6. How much is that? 48 or something? Yeah, 48. Nice. Okay, nice. Everybody getting through? Even the ones who not messaging at all. Dexter, are you okay? Ciara? Antonio, you there still? Okay, nice. Hold on, I'm gonna just message Amanda. This Amanda, yo. All right, good. A random sample of exactly 50 persons were introduced to the product. Calculate the probability that exactly 9. So you want the probability of exactly 9. Right? So X follows a binomial with with N 15, P is 0.6. Right? So exactly 9. That will be N C R is 9, right? By Q, which is 0.4, 1 minus 0.6, by 15 minus 9, which is 6, by 0.69. How much is that? They said exactly 9, right? If it were more than 9, then you had to work out all, right? Right, Jude got 0.207. Nice. Hey, Bear, get this one right, boy. In the game. All right, nice. Everybody okay there? I want a small break now, and then we do our next one. And I all did 15 already. Chelsea, I said Chelsea wants to know it. All right. Take a little break. We'll do 2015, and then I will focus on module 3, right? What time I tell you we're going until? 5. All right. Oh Lord, till 5 o'clock. Okay. Take a break now. How long all you want? All you home, eh? All that go and buy food, all that go nowhere. That's good. 12:52. Don't be mad. Eh? Oh, 12. Oh, yeah. Okay. I now see the time. I thought it was 12 o'clock. 12:34. Okay. All right. 1 o'clock fair. 1 o'clock, okay? Say 2-hour break. No, not 1:30. Where are you mad? We still have module 3 to do now. So after 2015, go over the continuous variable. Okay, all right, 2022, okay. All right, so you have until 1 o'clock. Take a little break and then we start back with 20, right? Right, I want to log out to save some log back in 1 o'clock, right? I just want to charge my iPad. Or you can log out and log back in. Right? You can log back in. Or somebody can become the host anyway. All right, so to do the 2015 quick, and then we'll check out the 2022, but that's one over something, and then we do the tree, right? Okay. And we do module 3. Are you up to 2015 quick? Right, as soon as I finish message, right? Yeah, 2015. Same numbers, 3 and 4. Same numbers, 3 and 4. Do it quick, and then let's All right, let's start correcting now. So at the cafeteria, it is noted that 50% buy French fries. Oh gosh, there's a question that worded kind of bad. At a cafeteria, it is noted that 50% of patrons buy French fries and 45% buy macaroni cheese. 32% of those who buy French fries also buy macaroni and cheese. Calculate the probability of both macaroni and cheese. All right, so what we got here for this first one here? Right, so 50% buy French fries and 32% of those who buy French fries also buy macaroni. Sure. So that's 32% of 50. How much is that? How much you got there? You here? That's 16. Right, so that will also indicate who to put, right? And the French fries only. French fries only will be 50 minus that 16. So that'll be 0.34. Then they want a Venn diagram. Right, French fries, macaroni and cheese. Right, this is, I'll do it in percentages, right? This will be 16. French fries only is 34. And mac and cheese is how much is that? 29. How much outside? How much people outside there? 45 plus 34. Right, that's 79, so that's 21% outside. Right, so this answer here is 21% or 0.21. Everybody okay with that? Everybody okay with that? Are there, sir? You're hearing, right? All right. So a sample of 90 person. Yeah, the first part it worded kind of weird, but they said 32% of those who buy French fries. So it's 32% of this amount, 50% buy French fries. So 32% of 50 is 16. So it appears that 16%, yeah, 16%, they buy French fries and mac and cheese. So that's the intersection part. Yeah, that wording was kind of weird. Right? Here, you kind of did something like this already. Remember, you do your totals most likely, right? This should be 90. This is 28, 36, 26. Right? Here is 20, 40, 50. And most likely here's 40. What's the probability that's a female? That's 40 over 90. Prefers Pepsi Cola? That's 36 over 90. Likes ginger ale and is a male? 12 over 90. Prefers Coca-Cola given as a female, right? Given as a female is 40. And Coca-Cola and female is 10. Okay? So that's some easy marks there, right? Next. This is looking like a tree diagram. We wanted to show all the possibilities. So a bag of sweets contain 8 coffee flavored toffees, 6 vanilla flavored toffees, all identical except for flavor. So you have 8 coffee flavored and 6 vanilla flavored. 3 toffees are taken randomly without replacement from the bag. Show all the possibilities. All right, so coffee, coffee, vanilla. Right, coffee, vanilla, coffee, vanilla, coffee, vanilla, coffee, vanilla, coffee, vanilla, coffee, vanilla. All right, so that's 14. Coffee, vanilla, coffee, vanilla. Right. So coffee, that's 8 over 14, and this is 6 over 14. Right? Why I put in F? You know what I mean, right? Right. Coffee, vanilla, right? So you choose a coffee, so that would have 7 remaining out of 13. Here you still have 6 out of 13. Here will be 6 out of 12. Here will still be 6 out of 12, right? It should always sum to 1, right? 1 coffee gone, so that's 7 out of 12. 1 vanilla gone, so that'll be 5 out of 12. Here you still have 8 out of 13. 1 gone, so that's 5 out of 13. Make sure it sums to 1, right? And on the third try here, 1 gone, so that's 7 out of 12. This will be 5 out of 12. Here, none gone, so that's 8 out of 12. Here, 2 gone, 4 out of 12. All right, think we should have it there. Right, given that the first coffee selected, toffee selected was coffee flavored, was the probability that the second selected will also be coffee flavored? So there's a part 1, right? Just take 2 minutes for those who didn't get the diagram right. Work out that fast. Right, they said given that the first was coffee, what's the probability that the second is coffee? Right, of course, this is 1 and this is 2, right? Right, what you'll have for this one? Given that the first is coffee, what's the probability that the second toffee is coffee as well? What you'll have for that? Right, very good. You just read it off the table because we are, the chart because we already work it out. Right? The first is coffee is 8 and 14, so the second coffee will be 7 and 13. Okay, calculate the probability that exactly 2 of the 3 will be vanilla. So you're looking for the branches that have 2 vanilla. Right, might have a few options. So that's here, that's 1. Here, that's 2. Here, that's 3. Okay, so that'll be 8 over 14 by 6 over 13. Right, it's 2 vanilla you're looking for, right? By 5 over 12 plus 6 over 14, 8 over 13 by 5 over 12 plus, what's the last one? 2 vanilla and coffee, right? 6 over 14, 5 over 13, 8 over 12. Right, and then you add it up. One person got 32, 30 or 91. Okay. Next one, number 4. You can screenshot it if you want. All right, number 4. An editorial team was examining the pages of a book of grammatical errors, the number of everything given there, right? X represents the number of errors found on the page. So now you have to get a probability distribution table. Okay. So just to find probabilities, when it's 0, right? When it's 0, what's the probability? That'll be 58 over, what was it total here? $350, right? So the probability again at 0 is 58 on 350, that's all. 74 on 350, 98 on 350, 65 on 350, 35 on 350. Okay, that's all you have to do. All right, and then, well, of course, you don't want this part here, right? That'll be a probability distribution table, right? They want it in the decimal, so you can work it out in decimals. They want the probability between 2 and 4, so that'll be 98 plus 65 plus 35. Okay, how much is that? 198 or something? Right, and then to get the expected number, you have to find the sum of x by p of x. So you multiply it out, multiply x by everything, right? Right, these are your x values here. Ampere got 2.01. Okay, any issues there? That's an easy 9 marks, right? Any questions, Eolia? Everybody okay there? All right, next one. A small business has 10 telephone lines. It is estimated that the probability that a line is engaged is 0.3. So looking like a binomial, right? Right, so it looks like y follows a binomial. N10 probability 0.3. Right, given that y is the number of telephone lines that will be engaged, assuming that all is independent, right? So it looks like a binomial. Find the probability of exactly 4, right? So that would be 10C4 by 0.7 C6 by 0.3 C4. Right? How much you got for that? .2, nice. They want the probability of at least 1, so the probability of at least 1, right? That should really be a y, yeah? Right, you just have to work out x is 0, right? How much you all got there? That's 0.7 to the power of 10. Sorry, 1 minus that. Sorry about that. 1 minus that. How much is that? Right, so you have to work out y is equal to 0 and let's minus that value from 1. .971. Okay. All right, next one. C. The results of the statistical examination follow an approximate right, the results of the approximate a normal distribution. So it follows a normal distribution with mean 68 and standard deviation 8. Grade A is awarded to students who score more than 82. Right? So students who score more than 82 will get a grade A. All right. So that will be get standardized first. So X is more than 82 minus 68 all over 8. How much is that? $1.75, right? So when you standardize, the X becomes a 0. So that will be is more than, so that will be 1 minus 5 of 1.75. How much is that? So when do we add? Oh, when is added on is only when you're converting from a discrete to a continuous. Right? So only when you have a discrete distribution like a binomial and it's being converted into continuous. That's the only time you apply continuity correction. 0.0 or 0.04. 0.0401. All right. All right, nice. Good. Right. Anything else in module 2? So I can go to module 3. Right. Somebody wanted to look at 20. I forgot what you said, Chelsea. 2022 number 3. Do me a favor now and share it here now. 2022 number 3. See if we can share it. Right, let me start module 3, right? Module 3 is your linear regression, right? Your hypothesis testing. Anybody have a 2022? A good one? Sorry for a minute. Let me check and see the one I have. The one I got. Oh, yes, that's true. The one that I had was on the website. I was kind of blurry. I guess we got to use that. It shows number 3. This one here, you mean? Oh Lord. I can barely see that. This one here, man. Yeah, okay. So in order for you to work it out really and truly, you should do the sketch first. I know they asked you to sketch after, but we can sketch this. So they set x over 2, right, between 0 and 1, and then 1 to 2.5 is key. So x over 2 is a line. It's basically a kind of straight line, right? So it starts in here. It might look something like that. That's x over 2. That's from 0 to 1. And then from 1 to 2.5 is key, right? From 1 to 2.5 is key. So how do we find the value of key? Well, key is this here is a horizontal line, right? It's a nice straight line. So how do we solve for key? All right. We have a few ways that we can solve for key. You might recognize, yeah, you can find the total area and make it equal to 1, or you might recognize that at this point here, k begins. So if I substitute x as 1, I'll get k. K is a half, right? Or we could do it like this, right? Let's do the area method, right? All right, so you have area 1, area 2. Okay. All right, so the total area, which is 1, is area 1 plus area 2. Right, area 1 is area 1 is half base by height. The base is 1 and the height is well, let's put k, right? Plus the next side is a triangle, right? The next side is a rectangle, so that's 1.5 by k as well. So 1 is equal to a half k plus 3 on 2k. So 1 is equal to 2k. So k is equal to a half, right? And then you could rub off k and put a half, and you have the sketch. That's okay? Yeah? All right, so nice. Okay, so module 3 time. Anything else in module 2? Anything else in module 2 earlier? All paying some all gone. Good chief, all you okay there? All right, let's start some module 3. All right, so I'll run through all the things that we need for module 3 and then focus on some module 3 things, right? Hold on, huh? Just want to share this thing. She got the place on the thing. Right, nice. So in your module 3, remember you have all the estimates, right? You have your point estimates, you have to develop your interval estimates, that's your confidence intervals, and you have your hypothesis testing. After you do that, you have to be able to do your linear regressions, right? So let's take a look at your, all right, good. I wanted to make sure of everything, right? You have your linear regression and you have your correlation, correct? Yeah, nice. All right, so let's start. So a point estimate is where you're going to actually estimate certain values, right? So to find the point estimate for the sample mean, that's your X bar formula, right? Sum of X on N. If it's a proportion, well, it's just like finding like a ratio, the number successful over the total number, right? Then if you want to get the sample variance, right? So if you want to get the estimate for the population variance, there's one formula, N over N minus 1, N over N minus 1 by S squared. Okay, S is from the sample variance. That's one version of the formula. And the next version of the formula could also be this, right? Sum of X squared on N minus sum of X squared by N minus 1. Right, there's a next version that you will see in your formula sheet that you could also use, right? All of those are used to estimate, the variance. Okay, so I want you to remember how to estimate those things. Once you estimate the variance, you can square root it and find your values, right? I really can't remember. I know I put a show earlier. Well, you could probably just Google and use a calculator, and it allows you to also get an estimate by just putting in the values. It's how to plug in the values and save it, right? And once you save your values, you could once you save the values, you could find the variance and mean. All right, so it's some useful, especially for applied. Right, and then there's something called the sample distributions of means, right? It's a special distribution that you're going to use with a whole set of means, right? And the standard, the distribution for mean looks like this, right? So if all your values come from a normal distribution with mean mu and variance sigma squared, then the distribution of means is mu, right? This is for means, so that should really have an X bar on top. That'll be normal mean by sigma squared on N. So this is called the sample distribution of means. Okay, right? So anytime you see mean, like when you're finding the confidence interval for mean, this is the distribution you're using. Whenever you do not have hypothesis testing and you're testing against the mean, this is the distribution you're using. Okay, every time you see distribution of means, that's the distribution you're going to be using. No longer using this one here. That's where all the means come from. All right. And well, central limit theorem is a theorem that you use to estimate it to be a normal. Right? You have to estimate it to be a normal. Right? That's when your sample size is very big, right? Okay, so that's all that notation there is about. So how do we find confidence intervals? Well, I gave you a few here. To find the confidence interval for mean, right? This is the general form. You always take your X bar, you minus by some critical sum value. If it's 95%, it will be 1.96. Actually, you're adding and minusing that value. And then you multiply by a standard error, which is sigma over root n. It doesn't matter, right? If the value changes to 94%, you have to find that particular value. Oh, wait, let me show you how to find that value, right? If it's a 95%, here's what they're referring to, right? If it's a 95%, they're referring to inside here. You want to be 95% sure that it exists, right? Which means that you want to get these values here. Which means that here and here, those two parts on both ends has to sum to 5%. So the value here will be 2.5%, the value here will be 2.5%. So in order for you to read off B corresponds to all of this here. B corresponds to 0.975. So you're going to go to your tables and in reverse, read off what value going to give you 0.975. And that value is 1.96. And here, since it's symmetric, that'll be minus 1.96. Okay? If it were 90%, right? Then here will be 5% and here will be 5%. Right? You'll have 5 and 5% there. Okay, and then you work it out. You read off for 0.95. Well, okay with that? So that will give you the critical value. Regardless of what percentage, you have to work out that critical value, right? Right, so it don't really matter. Right? Some people learn them off. You can learn off the popular ones like 90, 94, 95, 99. Right? I remember a year, anyway, I don't think you all have that anymore. There was a year that they used a formula sheet that had all of that on it. I think they took those away. Right, so, right, if you have a known variance, then you are going to use this here. If it's not normal, but the sample size large, right, you still have a known variance, you're using same thing, but you're going to have to use central limit theorem, right? You're going to have to state central limit theorem. Since n is more than 30, it will also follow a normal. Then, if it's unknown, if it's non-normal, unknown, and n is large, then we have to estimate. We have to estimate it, and then by central limit theorem, we work it out. All right? So nothing changes, the same format, right? The only one that's different is when n is small. When n is small, n is less than 30, then we're going to use a t distribution. So you're going to a t distribution. If you have 6 values, you're going to 6 minus 1, which is 5 degrees of freedom, and you're reading off the percentage they give you. Right? Here, look for 0.95, and you read it off. Okay, so that's the way you get a confidence interval. So you're checking for any of those 4 conditions, right? Okay. Note that the width of the confidence interval could be reduced in any of these ways here: increasing the sample size, decreasing the confidence interval, or reducing the size of the population. Right? All of those there can make the width smaller. That's the width is remember you have 2 boundaries, right? So the width is when you subtract those boundaries. All right, good. So that is your confidence interval here. If by chance they ask for a confidence interval for proportion, you're using this version instead, right? Right, this in the wrong place. Okay, proportion is just like having the ratio. So like if the proportion is 5 on 10, 6 on 10, then Q will be 4 on 10, and you're using this formula here. If you see mean, you're using the one I show you before with a proportion, you're using this one. Right? Then we need to know the basic steps in doing a hypothesis test. Right? These are your basic steps here in doing a hypothesis test, right? Number 1, state the variable using being used. Number 2, check out your H0, check out your H1, right? Your null hypothesis is generally where your mean is 0. So your mean is some value. Okay, and then your alternate hypothesis has 3 options: a lower tail test, right, an upper tail test, or a 2-tailed test. Right, we will do examples in each one. Well, We'll do a few examples. All right. Okay. After you figure out your type of tail, you write the distribution. Since it's a distribution of mean, you know what it look like. All right. It'll be normal with mean, mu, and variance, sigma squared on n. All right. And then based on the type of test, you develop a critical region. Right? If it's a lower tail test, you develop a critical region. If it's a two-tail test, you develop a critical region. Okay? And then you do your calculation to get the test value, and then check and see where your test value is. If your test value is in the critical region, you reject H0 to accept H1. If it's not, then you do not reject H0. Okay, that's it. Those are all the general steps in doing a hypothesis test. Okay, let's look at one of them here. These are for different values, right? It's a popular one here, 95%, right? So if it's a 5% significance level, it's a one-tail, lower tail test, and it's written like this, right? And since it's less than, we're going to reject. If when you calculate your Z value, you get something less than minus 1.645. So you're working out your probability of Z, right? And if you get something less than minus 1.645, then you reject, right? If it's a one-tail, upper tail test, is more than. If it's a two-tail, is less than the smallest, bigger than the positive. Or you could say modulus, right? If you never see that before, don't worry about that, right? Less than negative and more than the positive. Remember, it's a two-tail test, right? So it's here and here. Right? Notice the value change. When it's a two-tail test, inside here is 95. Outside here is 2.5, 2.5. Right? When it's a lower tail test, right? Here is 5. All here is 95, right? So that's why the value is changing. Right? And well, I gave you a few. I gave you for 10% significant, 5% significant, 1% significant, right? All those are the different type of tests. And then if it's an unknown population, right? X is normal. Of course, this is how you get your test statistic, right? If it's not normal, you have to state by central limit theorem, it follows this. Notice all of them following are normal, right? Right? If sigma squared is unknown, you have to estimate it. Like in this one here. This little hat on top means you have to estimate it, right? Any questions there? Right? And we have one more. Right? When the distribution is small, you use a t distribution. Right? So you use a t statistic in order to do this estimate. Right? And binomial looks something like this. Okay, so those are your hypothesis testing, the logic confidence intervals, and your point estimates. Last thing is regressions. Right? Last thing is your regression. Right? If you have a regression, y on x. Oh yeah, crap, chi-squared. All right, yeah, well, I'll do an example and run through chi-squared. I don't think I have chi-squared here. Yeah, I don't. Right, chi-squared basically, right, chi-squared, that chi-squared test is a test for independence. Right? So you have your H0 saying that they're dependent on each other. And you have your H1 saying that they're independent, right? Two variables, right? And you need to be able to develop a chi-squared, right? So you should remember a few things. They'll give you a table. You'll have all your observed values. Then from your observed values, you'll have to find your expected values. Then you have your observed minus your expected. And then you sum up all of that. right? That will give you a chi-squared test value, right? And then based on the significance level, we will reject the chi-squared, right? If we get something more than, you reject the chi-squared if your value, if your test value is more than the value that you had to estimate. Right, we'll do our examples so you would remember this. This is probably one of the easier ones, right? Once you obtain your observed value, your expected value, you use the formula and you work it out. All right. And then the regression. So if you have to do a y on x, right? A regression is basically your line, right? And you need to get your y-intercept. So if you have y is equal to bx plus a, b is your regression coefficients and a is constant, right? In order for you to get b, you use sx over sxx. If you do like this method, go to the formula sheet and you can use that formula there, right? For this method, you will have to learn these formulas, right? And then once you get your b, to find your a, you take the mean of y, the mean of x, and multiply it by b and subtract those two values. All right. And then you get your regression line. And you can use it to estimate any value you want. Right. Once you have your regression line, you could also find a correlation. Here you have a negative correlation. Here you have a positive correlation. All your values are between -1 and 1. Right. And these are the formulas here to find it. Right. Again, it have these or it have the ones that you have in your formula sheet. Okay. Right. And then, well, yeah, have some other little things that you can look at here. All right. So that's your module 3. Right. Of course, you need plenty of practice, right? So let's see if we can do more than 2 years in this one. Right, we'll do paper 2 first in this one, and then come and do the multiple choice. That's okay? Or you want to do the other way around? You want to do the multiple choice first or the paper 2 first? This one first. MCQ. What y'all say? We do one person answering. What do you want to do? Paper 2. Who else say paper 2? Okay, paper 2 first. Anybody else? Paper 2, okay, all right. Paper 2 in Chelsea. So start here. 2060. Try number 5 and number 6. I'll give you some time to actually try it. Right, they should have a chi-squared, I think. I think this year had a chi-squared. I remember seeing one. Oh yeah, look at it. So we'll check out that chi-squared. All right, go ahead, do the number 5 and number 6. Right, this is kind of where the little problem will be. This one. Right, go ahead. Sorry, talk just message when you finish number 5. You want to take too long. Antonio, you're doing it? Antonio? Antonio? All right, Barama. All right. Understand? Number 5 at least. You'll finish it. You're done? You'll finish up this one. Very finish up number 5. All right, so help me out here. X bar is equal to the sum of x on n. So that's 510 over how much? 49. How much is that? Nice, 10.4. Then they want the unbiased estimate for the standard deviation, right? So we know that variance, they gave us anything? Nope, that's all they gave us. So we'll have to use 1 over n minus 1 by the sum of x squared minus the sum of x squared over n. Right, we'll use this version here. So that's 1 over 49 minus 1, that's 48. Sum of x squared is 5635 by 510 squared over n, which is 49. Right? And then we'll square root that value. Right? Which will got the sigma 2.6. That's your square rooted value, right? Right, we had to square root this whole thing here. Okay, nice, that's 2.6. Good. So we have those two values, what they asked for next. Right, they want a 94% confidence interval. So x bar plus or minus for 94%. What's the value for 94%? Plus and minus sigma bar. Yeah, what's the value for 94%? The table value. $1.555, right? 1.555, right? Remember, you're going to table. If here is 94, you're splitting up the remainder, which is 6, right? So here is 3%. So the value you're looking for was 0.97, right? So your x bar value is 10.4. Oh, Lord Jude. 1.882. Anybody else got that? 1.882. $1.881. Okay. Right. So it will be 10.4 plus or minus 1.881 by 2.6 over the square root of 49. Or what are the values? Always remember, right? Your mean should be within those values, right? So you can't get like 20 point something and you can't get two values more than 10.4. One is less and one is more. One person has 9.7, 11.1. Yeah, okay, nice. So confidence interval is fairly simple, right? Sometimes in a question, they ask you to work backwards, right? So you just use the formula, take the limits they give you and work backwards. Or even if they give you the width, right? Subtract the two, get your width and solve for the unknown. Right? Remember your width is always 2 times this value, right? All right, nice. That's your mean standard. Next one. 60 random samples of 49 are taken at a 95% confidence interval. Right, yeah. At a 95 confidence interval for mu is found for each sample. What we did just now? A 94. Determine the number of appropriate intervals, that will contain population. Right? What will that be? So you're doing a 95% confidence interval for mu, right? And you have 60 random samples. What's the appropriate number of intervals that will contain that? Any ideas? How are you doing that? How many intervals out of the 60 will contain that? Right, so out of the 60, 95%. Okay, so you find a 95% of 60. How much is that? 57. So 57 should contain it. Right, 57 should contain it. Next one, the mean of 150 observations of X are given by that is X bar. Use the central limit theorem to state the distribution, right? So we always know that X bar should follow one normal distribution with mean mu and variance sigma squared on n. Okay, so we know what n is. That's the number of means that it took. Let's see if we could convert, because this value is so large, we had to convert that to our normal, right? So it would have been 135 by 0.36. That would have been the old mean. And then 135 by 0.36 by 0.64. That would have been the old variance. Right? How much is that? What's the mu value? 48.6. And what's the variance? 31.1. That's it. So we took the original data that was followed by a mean, that followed a mean, and we converted it to the normal because the n value is so large, right? The n value is so large. And then we use that information now, that's the 48.6 and 31.1, right? To find the new distribution modeled by X bar. Okay with that? Let's go again. I shouldn't have live streaming now. I'll make some more pay attention. A manufacturer, yeah, I'll put up the live stream now. Or them people watching. All right. A manufacturer claims that the mean mass of a certain type of soap bar is 110, right? So they give you the mean is 110. They said a random sample of 18 such soap bars give a mean of 105, standard deviation 6.7. Test at the 5% level, the hypothesis that the manufacturer is overstating it, right? So it's what type of test this will be? Huh? T? Right. Sorry, I meant like if it's a two tail or one tail or upper tail or lower tail test. That's what I meant, sorry. Upper tail, lower tail, or two tail test. Right, so your H naught. What's your H naught here? Oh. Well, I get to this one. I want you all to make sure and try it. Huh? I want to start it. I'm going ahead and, in fact, at worst, if you didn't do it, we could just do it together, right? All right, so let's take a look at this one here. So what will your X, what will your mu be? H naught, I mean. H naught is what? Right, mu is equal to 110, nice. Right, that's always on the population, right? And your H1 is your mu is equal, sorry, mu is what? Less than 110 or more than 110? Right, less than. Yeah, I would say less than. Okay. Right here, because they say it overstating, right? So either is equal to 110 or is actually less than 110. All right, so it looks like a lower tail test. Right, for those who didn't get to do it, try it fast now, please. Right, the sample size is small. Right, so you're doing a t-test. I just giving you a few minutes again. I want to make sure you do this, right? All right, so you should have the critical region by now. So what will be the critical region? Right, we reject H naught if what? Right, since it's less than T, follows a T distribution with 18 minus 1, and this was 5%. Right? So we reject if T is less than how much? Or if the table is how much? 17 and a reading of 0.95. Minus 1.740. Anybody else got that? Less than minus 1.740. Yeah, all right. One little thing, what they ask for after, the value of the test statistic, and then make a conclusion, right? So I'll come back here. All right. So they want the value of the test statistic now, right? That's where you have to go and calculate the value. So no, you're reading 0.95. This is a lower tail test. So you're just reading 0.95. 0.795 would have been a two-tail test. Right, yeah. So the T value, right, that will be a X bar minus, right? And I want you to be careful here. X bar minus your mu naught all over your sigma hat. Remember, we have to go and estimate sigma. This value here is your S. So to estimate sigma squared, we're using n over n minus 1 S squared. Right? Right? How much you got for sigma here? Well, of course, sigma, you had the square root of the whole thing, right? And your S squared value is 6.7. How much you got there? $6.89, right? So it'll be it'll be X bar, which is what we got from the sample. That was 105. Your mu naught, that's where you're testing against, that's 110. Right? And it will be 6.89 over the square root of n. Square root of 18, yeah, 18. Right? Bear got minus 3.1. Right? Since it's less than, we reject H naught at the 5% level. Right? And conclude that. Right? And then conclude that, well, H1 is true. Everybody okay with that? Any questions within it? Any specific questions? You okay with what I asked in part 1 and then part 2 and then 3 and 4? Right? It's important that you understand that this is a sample. This is the mean of the sample, and this is the standard deviation of the sample. Okay? So in order for us to get sigma hat, we have to estimate it, right? Any questions there? Aidan, any questions? All right. Let's go again. Do that, we do that. Oh, that's number 5. Okay. Number 6, you all get a chance to do number 6? Right, because I didn't show you a chi-squared, I'll do this chi-squared together with you, right? You did the chi-squared already, Antonio? All right, so let's do the chi-squared here together, right? Remember, in unit 1 is a test of independence, right? So the following table summarizes the responses of a random sample of 500 prospective voters to a survey on the voter preference of 3 candidates, P, Q, and R. So you have P, Q, and R, right? And you have all the values there, the sum it up for you. A chi-squared test is carried out to determine whether there's association between the age of the voter and that. So the first thing they want is the null and the alternate, right? Always remember, right, that the null hypothesis basically says they have no association, right? So you would say that there is no association, right? There is no association between the age of the voter and candidate preference, right? Or I could write it properly. I think the pen giving some trouble there. H1, you could say that there is an association, right? Right, so H0 is basically, you could say that they're independent, and H1, you could say that they're dependent. But you have to write this in full, huh? Not like how my pen wrote it there. Write this in full. Okay, so those are your first 2 steps. Then normally, I think this one gives you values, right? Okay, nice. They asked us to do it. So the number of voters in the survey who are over 60 years and have a preference for candidate P are shown in row 4, column 1. Row 4, column 1, right? That's right here. So they want us to get the expected value. So all these are your observed values, all of those, okay? To get your expected value, the expected value is always the row total, which is 81, by the column total that this belongs to, right? The row total and column total all over the grand total, right? That's how you get the expected values. Right? For those who did your project, you would have done it for each one of them. Okay? How much is that? Right? That's the way you work it out, and you have to do it for all of them, right? And then when you do it for all, you have to find the observed minus the expected, square the value, and then divide it by E. And then sum up that whole column. Right? And when you sum up that whole column, that will be a chi-squared test value. Right? That's the calculated value. Okay? How much is that? How much was the expected value here? How much y'all got? Remember, it was 81 by 202 divided by 500. That's for this person here. How much you got? 32.72. Nice. That's the expected value. Observe mine. So now they want the chi-squared value for that per here alone, not for the whole thing. So that's the observed minus the expected over this squared. Right? So that'll be 26 minus 32.72. You're squaring that, and then you're dividing it by 32.72. Right? When they say the chi-squared for that value, that's what they mean. How much is that? 26 minus 32.72. You square it, then you divide by 32.72. Right, 1.38. So that's the chi-squared value for that statistic. Okay, of course, you have to do it for all of them. In some questions, they would help you out and they would give you, like how here they give you part of it. You can just do it for one, but some questions you have to do all. Of course, it wouldn't be this big. I've never seen they give you a big one, like, what is that, 15 values? Right, probably like 6 values and 5 values. Right, so this is a chi-squared value for 26. Then they ask in the next part, they ask for the rejection region, right? So the rejection is always the same, okay? So you're going to reject you're going to reject H naught if the chi-squared test value, that's when you work out the whole thing, is more than the value from a statistic, right? Which is chi-squared, what was the test again? 5%, right? It was a 5% test. And the degrees of freedom, you have to check the number of rows and the number of columns, right? So is the number of rows minus 1 by the number of columns minus 1. Let's just check it back first and see how much it is. How many rows it have there? Right, so you would see 1, 2, 3, 4 rows. So it's 4 minus 1, columns is 3, 3 minus 1. So that's 3 by 2, that's 6. Right? So chi-squared 6, 5%. Right, go to your table. Read that off from please. Right, go to your chi-squared table. $12.59. So this value is 12.59. Okay. And now, if you look here in part 4, they said that the test value, the test statistic, right, that's this value here, is 92.195, which is more than 12.59. So therefore, we reject H naught and accept H1, right? So there is an association. Okay. Any questions? Everybody could read the chi-square table, right? Everybody could read the chi-square table, right? So you're going across the chi-squared. You're looking for 6 degrees of freedom, right? You're looking for 6 degrees of freedom. And because it's more than, you're looking for 0.05. And that's 12.592. Okay? So you're looking at 6 degrees of freedom and you're going across until the column on top is 0.05. Okay? And you're good to go. Right? So that's the way you handle a chi-square. Just sometimes it's a little more work, right? We have a few more things to do. Nice. Right, then we have a little regression here. We can actually do this one together because it's short. Yeah, this one's short. We can do this one together. What's that, Grant? How much for today? Today is 200 or something, right? Well, look at how we sorted out during pure months. All right. What I was saying there, right? So good. So they gave us a relationship here between cars and the value. X is 42, X is Y, XY, X squared, and so on, right? And they gave a regression. State one reason why the value of the car is dependent, right? Right? So the value of the car, right? Because the value of the car, right, depends or is related to how old the car is, how much the age of the car. Because as the age of the car changes, the value of the car changes. Okay? So the reason why the car is a dependent variable is because the price of the car or the value of the car depends or varies based on the age of the car. Okay? And you can see it's a negative correlation, a very high correlation as well. Okay? They wanted to do a scatter plot, calculate the mean, and then do a scatter plot, right? So a scatter plot is where you plot all the points, but you make sure that it passes through X bar, Y bar. So you must have that, right? It must pass through X bar, Y bar. And because you know the line, you could cheat and put in this as your y-intercept. Okay? Actually, because it's negative, I drew it wrong, right? So it might look something like that. And it must pass through X bar, Y bar. And then you plot all the other things, right? Okay, so your graph will look like that. So you must show X bar, Y bar, because that will be on your line, right? Actually, they only ask for the scatter plot. Okay, I think they ask for the line after. Right, on a diagram, so you draw the line after. So when you draw the line, you just have to focus on the y-intercept and the X bar, Y bar. It must pass through those two. Okay? And then using the data, with respect to the data, explain what does the minus 11.29 represent. So the minus 11.29, that's the regression coefficients. It shows you the factor by which the price of the car will drop for every increase in age. So 11.29 represents the factor by which Y, which is the price of the car, will drop. The reason I say drop because it's a minus. The factor by which the price of the car will drop for every year that the car ages. Okay. Then they wanted to use the regression line when the car is 7 years old. So you're taking 7, that's your X value, and you're plugging it in here. That's okay, Car? You okay with that? Antonio, you okay with that? All right, Canada. All right, good. So that's part 4, 5, 6. Interpret the regression. Well, you're seeing the correlation value, right? The correlation value here is negative 0.96, right? So it's a very high negative correlation or inverse relation. Okay? All okay with that? All right, nice. So that is your 16. All right, let's try a Some of our fields, some of them are not doing it. So we'll do the multiple choice, and then we'll do the paper 2. But break for what? Should boy just get a break? All right, 5 minutes. 5 minutes. Right? 5 minutes, and then we do all the multiple choice and the paper 2, 2015. Anybody who have any questions on other years that you would have done, we could all take a look at it, right? Right, so when you return, we're doing the 5-minute break, yeah? So that's until 20 past. When you're done, to do the multiple choice somehow. Same multiple choice, right? Right, while it's fresh in your head, try and do out a few years, right? You can check the Cape past papers. They have all the years. Well, not all. And I'll see in 20. Okay, so do that for now. The last 50. All right, guys, time up. Starting multiple choice one time for me. Okay, so you're doing 31 to 45. All right, Eden, you'll message all the answers to me, all right? You and Antonio. Anybody working still? Saskia, you finished? All right, hurry. I give you a few minutes again. Hurry up, Antonio. Tell me when you finish. Judo, finish, yeah? All right. Antonio, just waiting on you. All right, let's go. Let's correct it out. Good. Right. If samples of size n are drawn from a population which is not normally distributed, then the sample distribution of the sample mean is approximately normal if n is more than 30. See? Could we go with C there? 32. Yeah, no. Just tell me yes or no. In fact, just message your answer, right? And then we will see. 31 is C? C? Okay. 32. What you all got for 32? In a one-tailed z-test, the null hypothesis, mu is equal to 12, is tested against the alternate hypothesis H1, mu is 12. At a 5% significance level, the critical region is what? So we know it's more than, is a more than, so it's an upper tail test, right? So the z value that we have to read off is the one that corresponds to 0.95. 0.95 is normally what? 1.645? Yeah, B? No, C, 1.96. Right? B or C? I think it's C, 1.96. Right, 1.96, I think. Right, so it's 0.95. Remember, you're not coming here and doing this two-tail test thing. Huh? The only time that you're going to split up the 95 to get 0.975 is when it's a two-tail test. Okay, so you're just reading off as 0.95. Or one tail? Oh, well, sorry. So 0.95, 1.645, I really can't remember all. So 0.95 is 1.645. Okay, nice, boy. Right? 1.96 is two tail. Okay. All right, so the answer is B, 1.645. Chelsea, you okay with that? So if X is a chi-square distribution with 12 degrees of freedom and the value, was the value of X is less than 4.404. You just have to read this one off, right? 12 degrees of freedom. How much you got? 0.025. Okay. Everybody got B? Message your answers, please. Yeah, 0.025. You're just reading that straight off the table, right? 12 and whatever value you get here, and just read it off. Oh wait, there's less than. Hold on, let me just go to the tables. That's less than, eh? So 1, 2, 3, 4, 5, 6, 7, 8, 12. 4.04 is 0.975, right? Right, but because it's less than, look at what area is shaded. The more than area is shaded. So the answer is 1 minus that. So yes, the answer is boy. Good job. Right? Boy is the answer. 34, which one here? The test statistic, the T statistic is used to test the population mean when the variable X is what? Right, we know sample size small, so we can take off this, right? When is normally with variance unknown, right? So it's apple. Okay, apple. 35. They gave you a t-test is used to test whether the solar coils last an average of 5 years. A sample of 10, and they give you the mean and standard deviation. They want the value of the test statistic. So remember, we just did one like this. So we have to get x bar minus mu all over sigma hat on root 10. Okay. What do we have? We have x bar. They said the mean life of 6.75. Mu, they thought mu was 7. We have to work out sigma hat, that's the square root of n over n minus 1 by s squared. And then divide that by the square root of 10. What you all got for sigma hat? Yeah, how much you all got for sigma hat? Anybody else? For sigma hat, 0.53. Anybody else got a 0.53? And then work it all out from a place. Looking like a minus value. So not these are affiliates. Right, hurry up. Work out this here fast, please. Minus 1.5. But maybe based on what value you use here. So you're going with B as the answer. Yeah, we're going with B as the answer, right? Closest one. Okay. All right, so you're going with B. All right, let's go. If you use the estimate, what do you mean? Is 0.53? Well, you'll get some close. All right, so that'll work. Oh, so you mean if you use 0.5, you get minus 1.58? Yeah, well, you're supposed to use 6.75. What do you mean? If you use 0.5, you mean? Oh, okay. No, but you're supposed to use the estimate, which is 0.53. Or whatever this value is. The exact value. Next one. The items 36 refers to the following contingency table, which gives a result of a football team over 40 matches in good and bad weather conditions, right? So the chi-squared test for independence on the right, the expected frequency for the number of losses in bad weather. That's simple, right? That's 12 by 23 all over 40. Right? C, right? Now on the C there. Next, they gave you 5 values, test at a 5%, right? So you're finding the T value at 5%, 5 minus 1 degrees of freedom. How much is that? Go to your table and read the top, right? right? So that'll be 4 degrees of freedom, right? 2.132. Okay. Let's go again. Which of the following conditions is satisfied for the use of essential limit? Large samples are not taken. Small, so they're out, they're out. Right, so it's apple. Right, go with apple there. 38. The grades given by 3 teachers at a school is displayed by a 3x5 contingency table. Right, 5% significant levels is carried out to test. The chi-squared value is, test value is calculated. The critical region is chi-squared calculated has to be more than whatever the value is. Right, so that'll be what? 3 minus 1 by 5 minus 1. So that's 2 by 4, that's 8 degrees of freedom. 8 degrees of freedom, chi-squared, 5%. Right, so that will be what? B or C? B? 2.733? Yeah, B. Has to be more than, right? The regression line, y on x is what? Right, A sound like the best, A sounding real good. So we do have the regress, right? A sounding good. Answer is A, 41. To give you a chi-squared test of independence is carried out using a contingency table, right? So this will be 2 by what? 4, 8. 2 by 4, 8. Right? 8, 5%. How much? 5.224. Let me just get one letter. Right, Perry telling me 4 by 2. Where is 3 by 4? It's very say 8 earlier, supposed to be 12. Okay, so the answer is A, 5.226. All right, next one. What's the next one? All right, what's the next one? Oh, what's that, Celine? We're looking for 12 degrees of freedom, 5%. Wait, how will I get that? What shall I get for 41? E. Remember, it's a 5%. Right? Remember, it's a 5%, so it should be 21.026. So you're reading for 0.05, right? So remember, this is the value you're reading for 0.05, right? So you want to see what x is, right? And the degrees of freedom is 12. So it should really be something bigger, 21.026. All right. Oh, and now see the table that you all have is the less than table. Right, the table, those who use in the those who use the book, yeah, I forget this way. Those who use in textbook, the textbook is in more than. Okay, so those who use in the textbook is the one with the more than. So the right hand part shaded. Those who are using the what you call it, the document now, the one I sent, right? That's the less than area that's shaded. Okay, so we're using that wrong table there. Hold on, I just went and switch back to the next one. Right, so when is a, which one does give you? The one that you'll have there is the one that I'm giving you. Okay, so for those who use and saw what you wrong one there, sorry. So for the chi-squared, for this one here, right? For the chi-squared, 5% it was, yeah. Chi-squared 5%, 12 degrees of freedom. They're coming down to 12, and you're reading off. Hold on, yeah, they're coming down to 12, and you're reading off 0.95. Right? So you're reading off for this area here. Right? You're reading off this area here, which is 0.95. So this value here will be 21.03. Right? When you're looking at the more than side, right? You're reading off instead 0.05. All right, so 41 should be D. Right, let's check over the next one that we got as well, 39. Right, so this would have been chi-squared, 5%, 2 by 4, that's 8. So go back to 8. If you're using the less than table, hold on. If you're using the less than table, that's 8. So we're reading off 8, 15.51. So that's C. That's okay? So once your table is shaded like this, which is the one that you're going to get in exam, once this is the shaded region, you have to read off 0.95. If the bigger region shaded, you're reading 0.95. If the smaller region shaded, that's on the right, is 0.05. All right. Go ahead, yeah, ask the question. So are we doing any paper twos here? I would like to do paper two after this. I want to finish to the next year that we didn't get to do. The hypothesis testing, the probability of committing a type 1 error is called what? Which one they're looking familiar? No. Right, so if you look at the questions, right? If you look at every time you get a confidence, I mean a hypothesis testing question, what does give you? What does give you all you? Right, just give you a significance level. Okay, so a type 1 error, so the probability of committing a type 1 error is C, significance level. Okay, so 42 is C. 43, well, 43, what do you want, a confidence interval at 99? What you all got here? What a type 1 error? A type 1 error is when you reject H naught all the way through. Yeah, 43 is what? B? What's your 43? That's just for you to work out, right? A? All right, nice. That's just for you to use the formula and work out. 44 is what? The unbiased estimate for the proportion of students who scored less than 20. So you have to, the total is how much here? 40? How many people scored less than 20? What was 43? A. You got to work it out and make sure, right? 44 is what? How many people got less than 20? Right, remember not to include 20, yeah? It's less than 20, right? So what's the answer? A, B? Well, C and D out for sure, right? Hey, well, hurry up now. A, all right, so we're going with A. All right, A. Right, just remember, don't count 20. And last one. Last one. The mass of a bag of potatoes is normally distributed with a mean of 50 and a standard deviation of 6. Right, so you have a normal distribution. Sorry, X follows a normal distribution with mean 50 and standard deviation 6. 5 bags of potatoes are chosen at random. What is the probability to 3 significant figures that the mean mass of the bags is more than, of the 5 bags is more than, so the mean is more than 45. Okay, so we need to get X bar. X bar follows a normal of 50 and standard deviation what? It will be 6 squared over the square root of how much bags of potato? 5. Right? So we had to work that out. So we had to standardize first. Right? So that'll be 45 minus, here's the important part, right? Minus the mean, which is 50, over this value here, 36, well, square root of 36 squared, sorry, 6 squared over 5. Well, root 5, whatever value is that. Right? Whatever value is that. right? And then you go and read that off the table. What you all got? Right, so the key is this mean. Once you see mean mass, this is the distribution you're using. Right, it's looking like a minus, so it's more than a minus, so it should be a big value. One of these. D as in dog, nice. All right. So let's continue. Let's do one more paper two and we're done, right? What was the one that we did just now? We just did 16. All right, let's check out 15. All right, please do it. Right, 5 and 6, right? 5 and 6. Right, you all done with number 5? Finish number 5. Right, let's try it out. So they give you the value. They give you the value of the sales invoices for false and normal with a known variance. The random sample of 60 is taken, 95% confidence interval, right? So they want the width. So the width simple, it is subtracting, right? 12.54 minus 14.06. Then they want the mean, right? So you could work out the mean, and then they want the standard deviation. So you might have to kind of solve simultaneously here, right? So you will have to say X bar minus 95% is what? 1.96. What's 95% again? Come on, let's message quick now so we can run through this. Right, so it's 1.96 by X bar, sorry, by sigma under root 10. Right, we know what N is 60. Right, that value is the lower limit, which is 14.06. Right, rearrange, make X bar the subject, same thing here. X bar plus 1.96 by sigma on root 60 is equal to 19.54. Right? You work it out yourself simultaneously and you'll get your mean and your standard deviation. Okay? So just for you to solve it simultaneously. Okay, nice. Next part. Right, some people got 16.8 for the mean and 10.8 for the standard deviation. Anybody else got that? Yeah. Okay, nice. Next, they gave you they gave you E of they gave you E of X and variance, and they want the distribution for X bar. So X bar will follow on normal, right? Because sample size large, right? It will follow on normal with mean 25 and variance 144 over 81. Right? Here, all we have to do is standardize. Right? So that's 28 minus 25 all over the square root of that value. 144 and 81. How much is that? Anybody got that? Right, 2.25. Okay, so it's very straightforward for us to work out, right? Next, they gave you the mass of packages of spice from a packaging machine is normally distributed, right? So X follows a normal distribution with mean 48 and standard deviation 2.3, right? So variance is 2.3 squared. After repairs, the machine, to the machine, a package, a sample of 49. So N is 49, right? Gives you a mean. So this is your X bar, right? Standard deviation remains the same. Okay, state the null hypothesis and the alternate to determine whether the mean has changed. So your H naught here will be your mean is equal to the first value, which is 48. And here your mean is not equal to 48. That's the H1. So this is a two-tailed test, right? You want to see if it changes, if it's more or less, right? It's a critical value. They want to test it at the 4% level. So that is where, when they say 4%, here will be 2% and here will be 2%. So we check in to see if Z is less than something or Z is more than some value, right? So if it's less than minus 2.54, right? Because the value you're reading off is for 98, right? 0.98, sorry. The reading off will correspond to 0.98, right? Or if it's more than 2.54, right? Remember, it's a two-tail, so you're not reading off 96, you're reading off for 98%, right? And then you work out your value for your test statistics. So you work out your Z, that'll be your X bar minus your mu all over your sigma. Okay. Right, where we got minus 2.435, right? Which is less than minus 2.054. So therefore we reject H naught and conclude that there is a change. Okay. Anybody else got minus 2.435? Okay, nice. Right, so that's it, and then make a conclusion. Right, and that's it for number 5. Right, number 6. For each of the following pairs of bivariate data, that just means X and Y values, determine which variable is the independent, or which is the independent. Income of a family, monthly rent paid. So the independent variable is the X value, right? Which is this. So the income of the family determines the monthly rent. Plenty money, you'll pay high rent. Next, the advertising expense of a company and the sales of a company. The sales is dependent on the advertising expense. So this is X. What do you all think for part 2? Based on how much you advertise, that should increase your sales. Yeah. So yeah, we could go with that. Yeah. What do you all think? Yeah. Okay. Nice. The damage done to a certain home after a hurricane, the amount of money spent in repairs to a certain home after the hurricane. So the amount of damage should determine how much is spent. All on top is X, I will win. Okay. All right. So those are your variables there. Right, then you have your regression. So you're just doing your plot. You have your X and your Y, and almost all you do that because that's graph paper, right? You have your X and your Y, you have your X bar, Y bar, plot it. And then you draw your line, make sure your line goes to your X bar, Y bar. And then you plot this. Okay, you have your Y-intercept, run it through X bar, Y bar, and you're good to go. Okay, they said if a person is 22 years old, X is what age? Use the regression line to estimate. So you're plugging in. So you're plugging in X is 22 and solve for Y. Right? That value will be in days, right? So it'll be how much ever days. Right? So that's easy marks, right? Then you have a chi-squared. State the null and the alternate. The null is that there's no association, right? So there's no association between grade received and the school. The alternate is that there is an association between grade and school. right? So the H naught is no relationship. The H1 is yes relationship. Determine the critical value of tests of the 5% level of significance. So that would be what? Chi-squared. Yeah, everybody just check back this somewhere, right? Because some of you all got this wrong. 1, 2, 3. So that's 2 by 2. That's 4. How much is that? What's the critical value there? $12.59. Anybody else got that? 12.59. Push-ups. Yes, it's 8. It's 8. Sorry. Sorry. I thought F was total. It's 1, 2, 3, and fail. So it's 3 by 2, which is 6. All right. Sorry about that. It's 3 columns. So it's 12.59. Okay. The expected number of students. You all got that? 36 degrees of freedom. Yeah. Okay. Calculate the expected number of students who attended school B. Expected number who attended school B and received the grade. So that's for 14, right? So we had to get the row total and the column total, right? And the total. What was the grand total here? Right? So that's simple, right? Just add up this, multiply it by the total here, and then add up everything. And you get a total, right? Then they said the calculated value is 9.1265. Well, what you're going to do, reject H naught or accept it? Right? This value is less than 12.59, so we accept. We do not reject. Right? So we go with H naught. All right, any questions? Any questions earlier? Right, so spend some time and go over these things, right? Will you have any exam between Monday? No, I think most of all you have no exam, right? Anybody have an exam Monday? No, right? So you have some time, right? Do a couple more multiple choice. Any question that you get in trouble with, just take a little pic, send it from her with your working. I'll check it for you, right? So try and do about 5, you have about 8 years there, the more you could do better. Do about 5 years, if you start to see more than 30, 40 repeats, then you're okay. But the more you do, the better. It will increase the number of repeats that you will see on Tuesday. Right? And Tuesday, even if all I want to come out, I could come across and do some paper tools and practice, right? Go over all the years that we did. Remember, we did 17 to 2022, do over all those years. Right? So you get the practice, especially module 3. Yeah, that class should be free. All right, so they could come and practice if they need more practice. Okay, all right, so that's it. Right, won't do anything in the night, sir. So just if you need any help, just send practice and send little pick something. Okay, so that's it all. You have to log out. All right, I'll see some of you on Tuesday. All right, bye.